Good morning, everyone. Welcome to our session where we will overview a new graduate concentration in human factors in space systems design, developed right here at the American Public University System. Before we get underway, I wanted to introduce my esteemed colleagues. My name, by the way, is Dr. Ed Albin, and I am the department chair for the Space Studies program at American Public University. We have both an undergraduate and graduate program, and today we're going to be focusing on our graduate program in this wonderful new concentration. We are delighted to have JD Polk, Dr. Polk, from NASA with us here today, and he's going to frame this. JD is also a board member of trustees for the American Public University System, as well as the Chief Health and Medical Officer for NASA. His esteemed colleague, Arnold Nickagosian, is a faculty member here at the American Public University System, a professor who's been involved in the course development and is taking the lead with the development of this new concentration. And he is a former NASA Associate Administrator of Life and Microgravity with the Science Office. So we're delighted to have Arnold on board, who's worked closely with JD at NASA. And finally, my esteemed colleague and associate professor in the Department of Space Studies, focusing mostly on astronomy, has put a lot of work into this new concentration, Dr. Kristen Miller. And she is also an advisor for the American Institute of Aeronautics and Astronautics for our APUS student chapter. Has done a lot of good work there. Okay, before we get underway, I wanted to show the curriculum that we have developed here. There are 18 hours in the course framework for this graduate concentration, and you can see the outline of courses here. I'm not going to go through and read those. You can see those for yourselves. And today, the goal is to overview these courses and talk about the need for these courses. And we certainly are delighted to have you here with us today and would love to get your input. This concentration is currently still under development and will launch toward the end of next year, or perhaps January 2023. So we certainly invite your input. And having said that, let me hand it over to Dr. JD Polk from NASA to say a few words.
Thanks, Ed. And I'll share my screen here and pull up a few slides. And let's see if I can get the, there we go. Hopefully everybody can see that, and put it in screen view. I'm delighted that the university is offering, or at least beginning to offer, these human factors courses. Human factors and human systems integration are not interchangeable terms, but they collaborate together to help in the design of the spacecraft. And of course, at NASA, we have three main technical authorities: the chief engineer, the chief safety officer, and the chief health and medical technical authority. And the reason that the health and medical is in one of the three main tech authorities is because of this human factors, human systems integration, and the changes that we see in physiology, especially on orbit, and how that plays into the design of spacecraft. And just to give an idea, we on long duration missions, we do see a change in vision due to intracranial hypertension and optic nerve swelling of the astronauts. And so if you look at the upper picture, that's what an astronaut would see on launch but on landing, if they had a 1.5 diopter shift, which we have seen in astronauts due to this optic nerve edema and the intracranial pressure, this is what the vision would be coming home. And so, being able to design and think about those, it could be just a change in the glasses prescription, but it also could be as we move to new spacecraft and the glass cockpits, being able to change the font or the size of the font and the integration to allow for those changes in space physiology. And they are very important in those human factors design elements. And you're just coming home. We've seen multiple different spacecraft, and we have 3 capsules that we're working on right now. We've got the SpaceX capsule, Boeing, and Orion. And this gives a graphic for what the optimum angle of attack for the human body as you're coming through the atmosphere in that capsule. And it's actually fairly small. We normally have it at about 0.2 to 0.5. And if you have the astronaut's head down too low, they can get what's called red out, too much blood in the brain. And also they've already got intracranial hypertension and some swelling that could cause bleeding or some other deleterious problems if they are too low. If they are too high, not enough blood flow going to the brain, and they could pass out. So there's a very narrow margin or sweet spot, if you will, for the seat angle for astronauts as they come through the atmosphere in a capsule. And so, being able to design and teach those things, I think, are really important. The one thing that NASA has done is to try to now educate the commercial side of the house. And we've all seen the commercial and private industry expanding. But I think the one thing that NASA maybe underestimated is the speed at which the evolution of commercial spaceflight was going to take place. And just to remind folks, this was Sir Richard and his flight just a couple of months ago. But that was followed quickly a month later by Jeff Bezos and his flight, both of those being suborbital. But then, just landing a few days ago, Inspiration 4, which was an all private commercial astronauts doing an orbital flight for 3 days. And most of you may or may not know that on the heels of that, the Russians are flying private commercial astronauts to the ISS to do a movie, and they are, the crew will stay there for 6 months. This is a 6-month mission with private astronauts aboard. So you've gone from suborbital to a 6-month mission in literally 3.5 months, and in the time period of this year. And then potentially by December, the Dear Moon mission, where SpaceX is working with the Japanese billionaire to talk about doing a flight around the moon. So think about the speed in which those things are occurring. Normally you would see maybe suborbital space flight and then several years later get to orbital or to something that is interplanetary or out to the moon. But literally in the span of several months, we have progressed that rapidly. And so it gives you an idea that the human factors and human systems integration are going to be a very necessary educational commodity for many of these private and commercial industries, as well as for NASA, and as well as potentially for the Space Force in the future. And with that, I'll stop there and stop sharing.
Okay, thank you so much, JD. That was very informative and really puts the importance of our new concentration in the framework of how this will fit in and why we should be doing this. Okay, I'm checking to see if we have any questions. If you have any questions for JD, feel free to put them in the chat area. And what we're going to do now is we'll transition over to Dr. Kristen Miller, who will talk about the exploration of environments and really which will set up the overall outline for our new exciting concentration here at the university.
Thanks, Ed. I'm going to go ahead and share my screen here. And thank you to both to Ed and JD for a great introduction to the concentration. We're really excited to offer these topics, and I'm excited to be here today to tell you a little bit more about some of the topics that will be covered within the concentration. So my talk is going to focus on space environments and astrobiology. So why are we including space environments and astrobiology in this concentration? There's a couple of really good reasons, and one is that understanding the space environments, it helps us to understand how humans can live in them, and it also helps us to develop mitigation technologies as well as more efficient and effective and safer human habitats. It also guides us in developing technology, which can be a substitute for biological adaptation. Astrobiology is important because understanding how life can evolve and survive in extreme environments helps us understand how to support life in those environments. And space is definitely an extreme environment. It also factors into planetary protection, both forwards and backwards, which is always a key component of space exploration and settlement. There we go. So these topics fit into three of the courses of the concentration that Ed introduced. They'll be introduced in the first class in the concentration, where we'll talk about what the space environments are and give an introduction to them. And then later on in the concentration, we have a course on human exploration and life in the universe, where we'll cover astrobiology, extreme environments, and extremophiles. And finally, in a third class on planetary destinations, where we'll focus mainly on the environments of the Moon, Mars, and the asteroids. We'll also talk about planetary protection. Okay, so when we talk about space environments, in this concentration, we're mostly focusing on 4 different environments: low Earth orbit, the Moon, Mars, and asteroids. And each of these is distinct, and we have different experiences with each one and different data to guide us in each of these environments. So low Earth orbit is easily the most explored, and where we have a relative wealth of data compared to the other environments on the human responses and human experience surviving in this environment. We certainly have the most number of humans who've been to low Earth orbit, and the most culturally diverse group of astronauts in this environment. We also have both the longest cumulative amount of time in the environment and the longest total amount of time, looking at multiple missions together. So low Earth orbit, we do have information that we can apply to the other environments. When we look at the Moon, we certainly have a much less culturally diverse group of astronauts who have actually set foot on the Moon. We also have a significantly less amount of time on the Moon to learn about the responses there, 80 hours compared to hundreds of days and on the International Space Station. We've had significant rover exploration of the Moon from several different countries. We've covered about 140 kilometers total. On Mars, we have not yet put a human presence on Mars, but we've explored it in depth from orbiters. And again, we have some rovers on Mars. They've covered roughly a little bit more than 70 kilometers total, so a little bit less than we have on the Moon. And then we have asteroids, which we've neither sent rovers nor people to. We do have a couple of landers that have been on there. And the thing that's significant about asteroids is that those landers have each brought samples back. So that is different from Mars, where we have yet to return a sample. From the Moon and the asteroids, we both have sample returns. The Japanese have their samples, and OSIRIS-REx is scheduled to deliver ours hopefully in 2023. So when we look at these environments in a little bit more depth, each of these environments has unique properties, it has unique hazards, and it has unique potential. And the better we can understand the properties and the hazards in each environment, the better we know how to use the data that we've gathered there to direct and plan for our human settlements and exploration of the other environments. So we start with low Earth orbit. which has unique conditions. Certainly there's microgravity there due to free fall conditions. It is within the Earth's magnetosphere that's unique to this environment compared to the others, which provides some protection, at least from the solar energetic particles. One of the unique hazards in lower Earth orbit is space debris, which can impact and cause structural integrity damage. There's also a unique hazard in regards to solar storms because they can affect the Earth's environment, and the Earth's atmosphere and the upper layers can expand, increase in density, and affect even the orbits of the space station. There's a lot of potential for low Earth orbit in terms of people have talked about, of course, we have the orbiting International Space Station there. There's potential for other laboratories, manufacturing and microgravity. Space tourism is something people have started to talk about a lot, and the possibility of circumplanetary flights utilizing a lower Earth orbit. Now, when we look at the moon, we have a lot of the same environmental properties in terms of a lower gravity, although it's not microgravity, it's about a sixth of the Earth. We also have extreme temperatures. The temperatures listed here are for the equator. There's a little bit less variation day-night in terms of the poles, which are of interest for space settlements due to the resources there. But there is a huge variation in temperature at the poles when you compare the shadowed regions of the craters compared with the rims, which are in constant sunlight. So there is still a vast difference in terms of the environment. There's some specific hazards on the moon. Certainly the lack of the magnetosphere means a much higher radiation exposure on the moon than we see in low Earth orbit. There's roughly, the current estimate is somewhere around 60 microsieverts per hour on the lunar surface, which is about 200 times the exposure that you would get on Earth's surface. And significantly, exposure to cosmic rays is about 2.5 times higher than what the astronauts experience on the ISS. But working with NASA's limits on radiation exposure, it still allows for significant time on the moon. The moon has a lot of, and regolith dust, which is very different from dust on Earth, and it's quite abrasive and can cause both equipment and health hazards. So that's another challenge of the moon. There's a lot of potential on the moon. And NASA is excited about the Gateway project, an International Space Station around the moon. There's also a lot of interest in mining settlements. The moon, we believe, has vast expanses of water, which can be used for, human habitation, as well as fuel, radiation shielding, etc. And it also has helium-3 and rare earth metals, which could be mined from the moon. In terms of Mars, we do have different conditions than the moon. We have a little bit of atmosphere on Mars, although it's 95% carbon dioxide, and so not really breathable as is. But there is some atmospheric pressure there, much lower than Earth, also a different gravity. The carbon dioxide toxicity is a specific hazard that's unique to Mars out of these environments that we're talking about. There are also dust storms on Mars, which affect life support equipment and navigation, so that causes a unique hazard. Decompression sickness for EVAs is another unique hazard of these space environments. One thing that's interesting on Mars is the possibility of using the Martian soil to protect from radiation exposure. About 5 meters of soil can provide quite a bit of protection, so that's an interesting option to explore. There's a lot of potential that we're interested in on Mars. There's the possibility of a Martian settlement, the possibility of terraforming, and we've gotten a tiny little taste of what that might look like with the Perseverance rover. There's also mining of Martian resources. They have a lot of resources, iron, magnesium, titanium, things that we're very interested in, and things as well as the carbon dioxide and water in the ice cap, which could be used to support a human settlement and create fuel. And finally, the asteroids. So the asteroids are a unique environment, very different from the other objects. They're not planetary, and so there's some other interesting difficulties in terms of getting humans there. One of the problems, of course, is, or one of the challenges, is landing and working on a rapidly rotating body. They do have, they're known to carry a lot of rare earths, some really important minerals that we would love to mine, as well as vast quantities of water. So in summary, the environments are harsh environments for sure, but they're not impossible with proper planning, with proper mitigation strategies, and with proper materials. Okay, so astrobiology. Astrobiology is the study of life. And the reason that it's important to this concentration is that it helps us to understand how life got started on the Earth, where it got started on the Earth, where it can survive on the Earth. And understanding this will help us to know how we might be able to survive elsewhere, and also just understand the development process of life itself, which has implications for finding life elsewhere in the solar system and possibly even in the galaxy. Astrobiology and habitability are two primary concepts that we'll be discussing in the concentration that we'll really study in depth. Astrobiology is the study of the origins and development of life, whereas habitability is the study of the potential of a celestial object to develop and host life. They're two different concepts, but they go hand in hand. Okay, so in the concentration, just to give you a little taste, we're going to look at a couple of fundamental questions, and the things that we'd really like to know. We'd like to look at how life originated on Earth. We'd like to look at whether there is evidence of extinct or extant life in our solar system. We'll look at whether all life is water-based, carbon-based. It is on Earth, but that doesn't necessarily mean that it is elsewhere. We'll look at the definition of life beyond the distinction between innate and living states. And we'll look at what environments are conducive to the development of life. Recently, we've learned in our study of extremophiles that those environments have a much wider range of properties than we previously believed, and that there are organisms which are capable of living in environments that would be very difficult for human beings. So we'll start with a discussion of life on Earth, which is water-based and is carbon-based. And the intriguing thing is that these elements are very common throughout the solar system and throughout the galaxy. One of the things that makes water so helpful is that it can maintain a liquid state over a wide range of temperatures. It's polar, which facilitates bond formation, has a high surface tension, so it can flow, can have capillary action, is available in large quantities. We know that there were large quantities of water and organic materials, and they're prevalent in the solar nebula. So that's one possibility of where water could have come from. We've found in asteroids that there is a lot of water, and there is some indication, at least in the ones that we've been able to study in depth, that that water matches the deuterium-hydrogen ratios that are found in Earth's water. So that's intriguing. We've also found organic materials on Earth, and some experiments have indicated, or some calculations anyway, have indicated that complex organic molecules can survive an impact of an asteroid with the Earth. We've also seen some clays in some of the comets that we've studied, which has implications for finding as a medium for organic life developing into complex polymers. We also know that comets contain vast stores of water. There have been some observations that seem to indicate that the water in comets does not match the DH ratio on Earth, and then there are others that indicate that maybe it does. So this is an area of active research that we'll explore the concentration, and again that we will look at whether what the impacts would do, and whether simple organic chemicals would be able to be brought in this manner. There are many experiments that show that the energy that would be provided by the impact may be enough to turn simple organic chemicals into complex amino acids or into even peptide chains. So that's an exciting possibility. After we study life on Earth, we'll consider some of the possibilities of its origins. We'll consider all the possibilities that are currently being discussed, but we'll focus in particular on chemical evolution and cosmic origin. So chemical evolution stems from the Miller-Urey experiment, which used a reducing atmosphere, simulated atmosphere, and looked at an energy spike in there that could maybe create organic compounds from inorganic constituents. It's important to know that while they've been able to create organic compounds under specific conditions, that we have yet to see the creation of a fully developed living soul, or specifically of amino acids in these conditions, but it's an intriguing possibility. Cosmic origin takes a different look at it and thinks about seeding from space. Organic molecules could possibly be brought to Earth by comets, asteroids, and meteoroids. These organic molecules are likely to be found throughout the solar system. It's unconfirmed, but we believe that they would have been. There is some preliminary evidence, which is unconfirmed, that there may be some organic molecules in places such as the clouds of Venus. I think we may find it on Mars, and we're intrigued with the impossibility of finding it in some of the water moons or the ice moons of the outer planets. So the cosmic origin theory is known as panspermia, and it's the idea that microscopic life forms can be transported through space and brought and seeded on our planet to start life. We'll also look at extreme environments on Earth, and we will look at the organisms which are capable of surviving, and more than surviving, thriving in those environments. There are 6 different kinds of extreme environments that we'll study. They can relate to temperature, both very hot and very cold, pressure, high salt environments, acidic and basic environments. These are interesting because these sorts of environments will be found throughout the solar system in a lot of different space environments. So it has implications for what we may find in space environments, as well as can give us lessons on how to survive in them. There's 2 extremophiles that are particularly intriguing. One of them is the Nickagosian radiodurans, which is colloquially known as Conan the bacterium. This is a polyextremophile that can survive in conditions of extreme cold, dehydration, vacuum, and acid. It can survive ionizing radiation. We know that it can even mend double-strand DNA breaks. There are also the tardigrades, which are colloquially known as the water bears. This is another polyextremophile. It does well in both extreme heat and extreme cold, high and low pressure. It can survive in conditions of dehydration, vacuum, radiation, and starvation. And both of these have been shown to survive exposure to space. Polyextremophiles have big implications for our search for life, both our understanding of its origins and its evolution, and also the potential to find it in other planetary bodies. And it's expanded our view of where life has and can originate and thrive on Earth. So studies of the limits of life, these are important because they can help us to understand the potential for panspermia. They have implications for forward contamination due to human exploration ventures. They can help us with planetary settlements by humans, as well as the exploration of extinct and extant life. And finally, in the concentration, we'll explore the history of astrobiology. We've got some of the key events noted on this slide. It's really fairly young science. The term astrobiology was actually came into existence as early as 1995. A year later, we found what we thought was potential evidence of fossilized bacteria on a meteorite in 1996, and it started a lot of interest in the science. And even though that may not turn out to be so, it has fueled the astrobiology field. We've started adding astrobiology experiments to robotic missions, and NASA came up with the Research Coordination Network. It's really taken off in recent years with the analysis of samples from asteroids. There's the Itakala sample, which showed that asteroids have both water and organics. It's a significant discovery. And then today, with Perseverance and Ingenuity on the surface of Mars, where they have specific instrumentation that will allow them to look for both chemical signatures of life as well as actual organic materials on the surface of Mars. We also have a sample return potential with the Perseverance mission, which is very exciting. And looking forward in 2027 with the Dragonfly mission to Titan, which is an intriguing and in some ways analogous Earth-like environment, as well as the Clipper mission, which hasn't yet been scheduled, but would search, would explore Europa. And finally, with planetary protection policies, planetary protection is important in our studies, both in terms of protecting the Earth as we start with space, as we start to move forward with the space exploration. We want to make sure that we're protecting against contamination of the Earth and minimizing danger to astronaut exposure. We also want to look forward and protect life and the space environments that we'll be exploring. So that's just a brief introduction to some of the exciting topics that we'll be covering in the concentration. Thank you.
Thanks so much, Kristen. That was a great overview, and really looks like you are well into developing specifics in the curriculum. And speaking of the curriculum, there is one open question for you. Felicia Oliver Owens is asking, would these courses be writing intensive, or will there be other ways, let's say quizzes, labs, etc., to be graded?
Well, that's a really great question. So, you know, as a student who might be considering taking the concentration, those are the things that you really want to know, right? That's important information. This concentration is a master's level concentration. So yes, there will be an extensive writing component because that's appropriate for a master's level course, but there will be other forms of evaluation in the courses as well. We'll have discussions, there will be quizzes, certainly exams. So we're looking at a variety of projects and different evaluative methods.
All right, thank you so much, Dr. Miller. And we're going to go ahead and transition over to Dr. Nickagosian, who will tell us about some of the work that he has done with human factors in space systems design, and also the commercial and military space, and how contributions to human, how these can assist in the contributions to humans in space. So I want to hand it over to you, Arnold. And it looks like you may be muted. May need to.
All right.
There we go.
I'm trying to share the screen and to see if I can use the.
And while Arnold is doing that, in his background, I have to tell you, you are seeing the command module of Apollo 17, and Arnold was on the recovery ship representing NASA and its medical courts. I believe it was the USS Ticonderoga, correct?
Ticonderoga.
Ticonderoga. In recovering the astronauts, including our only scientist, Jack Schmitt, and of course, the effervescent Gene Cernan from the ocean, bobbing around in the ocean after successfully exploring the moon. Okay, Arnold. Looks good. Your slides are up. Thank you.
Thank you, Ed. That was a great show last night. I enjoyed it very much. I wish you could have shown me Bennu, because I would like to see how it's going to impact the Earth. But you did scare me about us going to Andromeda, having a collision, though it's about what, in about a couple of millions of years away?
More than 10 billion.
Okay, good.
10 billion years away, so we have plenty of time. Don't lose any sleep about being wiped out.
For JD, who did such a great presentation, facilitates to shorten mine because they explain things so well and in concise terms. Every 500,000 years, Earth gets hit by an asteroid, right? So JD has something else to worry over his complex job that he has now. All right, Yeah, the reason I put the picture of Apollo 17, that was my first mission when I came to NASA in 1972. That's how ancient I am. JD and I share a unique experience that we were crew surgeons for many missions and had to take care of the astronauts and did also experiments. The reason I put Apollo 17 because I want to remind that we were thinking then that we're going to return to the moon, and we didn't. That was 1972, 60 years or so plus. But now we are talking again about getting to the moon and beyond, which is good. And just to remind you that NASA has the largest number of crew members who've flown short duration mission, and now NASA is accumulating longer and longer mission durations to understand the long-term effect of space travel and reduced gravity. And I am sure that JD is doing all those things to improve the safety and the health of workforce, and also to understand the differences of gender, race, and sex in space. Can you see my slides? Yes, okay. So moving along with the slides, I would like to have a disclaimer that most of the images are courtesy of NASA and FAA. Information is extracted from published literature or drawn from our textbook, Space Physiology and Medicine. And I have no conflict of interest using with this presentation. What is the motivation? Follow on Kristen superb presentation, and I was kind of amused when I saw the picture of the tardigrades, and was going to remind Kristen that we have a life in the universe, tardigrades on the moon, okay? Though they are dormant, they can survive. And again, the motivation for my section is to explore future commercial opportunities in low Earth orbit and beyond, identify critical technologies, prepare for future in space manufacturing and services, address space travelers, workers, and defenders' health. That's what most of those things is JD's office is involved in, not NASA, and discuss human safety design drivers. Obviously, we cannot, those are the topics which will be part of the consultation, but obviously I won't be able in a short period of time to go over all of those, though many of the consultations are already, courses are already in place. So just to follow on what Ed and Kristen presented, I will be addressing some of the materials in 619, 620, 624, which are different stages of preparation, and 619 is complete. The materials is based on space physiology and medicine, and we are preparing a new textbook because, like JD said, in a very short period of time, a lot of things changed. One, we got new information about long duration space flight that we didn't get otherwise from the Russians. I remember the Russians were telling me that you guys are flying short duration missions, but wait till you get to long duration missions. And I always wonder what that meant until we developed the space station. But one thing really, being a student of public health and teaching public health policy at George Mason University, one thing sticks in my mind, that if it's even expensive, do it right the first time, saves life and cost. So one of the principles for this course is, for this consultation, is trying to instill to the students, what does it mean to do the right thing? And why is it evidence-based information, or whatever NASA started to do to collect all the past experience and lessons learned is important, is because it will help us to do the right things in the future, since we will never be able to get the full understanding of what are the difficulties facing us in long duration missions in reduced gravity. So what are the topics, the major topics in the course? It's a medical and health requirement for expanding to low Earth orbit, moon, asteroid, and Mars exploration in situ resource utilization that Kristen mentioned. Advances in exploration technology are lowering space access and cost. We are looking forward to that because more people will be flying. We know that inspiration for one of the medical technician who flew Arsenal, she is from a hospital which is in Virginia, the Medical Center for Cancer for Children Research. She's a survivor of cancer and had a leg prosthesis. So that's the first, I know that Isakovich was the commander, flew that mission, but there are things which are changing. I was totally surprised to know that the commander started a company which is training people to fight, training people how to fight different aircraft called the opposition force, which is really servicing the Air Force and many other countries with hundreds of airplanes from different countries made available, and something which reduced the cost for the Air Force training, just a side note. And I know that JD is looking at privatizing some of the crew training and for NASA, and which is already in progress. It is worthwhile to note that the new era that we talk about, the acceleration of commercial whatever, was kicked off by NASA actually. As the space shuttle, end of the space shuttle approached, NASA tried to start new programs in the commercial, brought the new enterprises in. Elon Musk would have never been able to do it without NASA. There are lawsuits and things like that going on. A hiccup at this point. But NASA is also now, and JD, please correct me, NASA is now receiving proposals for funding commercial space stations in the future, which will be beyond the ISS lifespan of end of this decade, 2028 or so. So really, it's less about billionaire space race, but most about what's in the future. Remember that in 1930, when we have American Airlines flying, the equivalent in today dollars ticket to fly coast to coast was about a little bit less than $4,000. Well, the price to ticket to space is about 50. The seat is about 50 million, with additional costs that NASA published going to ISS for food, potty, life support, and water, and whatever else. Okay, so it's expensive to go to space, and it is a really billionaire race to reduce the cost. But once one start to looking at 3D printer, and that SpaceX is using 3D printer engines, and the Relativity is putting together, rockets which can be, which will reduce the cost, they claim, to $1,000 per pound payload per low Earth orbit, but and rapid turnaround and rapid production in months as opposed to years, things are going to change much faster than we think. So we need to instill that into the students and to understand, in addition, improve situational awareness, like Zubin was talking this morning. And what people are starting to ponder, what do we do with space traffic management and low Earth orbit monitoring and defense against the asteroid? moving along, so what is the principle that we are addressing? Health risk and hazard. Well, we are imparting a rapid adaptation to the new environment using technology. And when you look at the health, technology, and environment, the technology is supposed to protect the humans against the environment, provide safety, and reduce the exposure risk. But the technology can induce also risk, and that should be factored in. It's not only microgravity who does that, radiation does separately, but the technology is also a threat, and that needs to be put into context of the human factors altogether. And also, we need to really address the ethics, like many people spoke about. So the basic human needs, and I will not dwell on that, it's, in space, you have to produce basically everything, And though we don't manufacture anything in space, but we produce air. We recycle most of what we produce air, except for nitrogen. And when we talk about resources that we need on the moon, on Mars, that's nitrogen, which might be found in the soil of Mars, or maybe produced from plants who can grow and fix nitrates in the soil and get nitrogen, as opposed to launch nitrogen all the time in space to space, which is really costly. And also think that water production today, we really produce 90% of the water recycling on orbit, but we have to bring some water. And I always joke with some of the taste of Moscow River that Russians add some materials to make it more tasty. Just remember the Mother Russia. Okay, so what are the core medical requirements for astronaut performance? And basically, we need to make sure that we can maintain crew performance post-flight. Oh yeah, that's me on a Skylab recovering the crew, and I had more hair at that time, looked better at that time. But anyhow, you age. But anyhow, so the space shuttle that we were involved, there were major differences. We were getting people doing Apollo and Skylab on aircraft carriers, fishing them out of the water. What did we do? With the SpaceX, we are back recovering people on the in the water. So things do repeat themselves. So what did we learn? And we are going to have recovered people on the ground. The shuttle so far has been providing the softest landing element of any spacecraft that was flown in the past. But yet it had problems also. And we need to make sure that performance is maintained in space in the future, which is after long duration missions, especially after the twin studies, which hinted that performance, there might be a decrement of performance. Sorry, allergies. Performance because even Soviets and Russians described that there are 3 phases of adaptation, mood adaptation in space, where you have, you adapt despite motion sickness and things like that. You pick up your pace, but then you might have some problems living in close quarters with people and with other people, but then you work very well. And after a while, if you get overloaded, like with missions, then I'm sorry, I got another message. Then you will find that you start to get tired, and then toward the last part of the mission, you're looking forward to return to Earth. So, what people describing, people invent the wheel. They say, performance is a decrement of performance. I'm not sure that's true or not. It might be this isolation and remoteness and overload, working overload that needs to be looked at it more carefully. So, so basically, there are two things which matter besides isolation and close proximity and social interactions. There is a removal of gravity gradient, microgravity, and radiation. Those are the things which have affected long-duration missions. And while some acute responses, like JD pointed out, are adaptive, they also can have chronic responses, which can have some symptoms, and they present medical risk, which is in some case the radiation produced stochastic and deterministic carcinogenicity, and we don't know really what the twin study about genetic alterations are telling us, because what they said is that, I don't know, 1,142 gene, 1,000 whatever gene did turn off and on, but they return back to normal, including the telomeres, which is a sign of aging or youth, which went back after return. So that needs to be further explored, but cannot be explored in the context of a small sample size, and that needs to be understood better. So we need to teach the people what are the major life-sustaining system and the technology and the category risk. We talked about water. 90% is recycled. What about the rest of it? We should not be, if we go away as a civilization, then we need to make sure that we are self-sufficient. Breathable atmosphere, we talked about where O2 can be produced on Mars or on the moon. Food system will be very important. Today, we start to produce very little of fresh food, but we need to really speed up. And Biorack, I think, is the one which is involved, is a commercial capability to do experiments on biological experiments, which is really providing that opportunity for commercial entities and NASA scientists to do some research to understand what the food production is. Well, hygiene. Preventing illness and injury is an important part. You need to maintain habitat clean from waste and debris. And JD and I can tell all kinds of stories about that. But pre-flight health stabilization and microbial control is important, given that there is a change in microbe make and resistance to antibiotic in space is possible, has been demonstrated. So decision about government-sponsored crew and commercial participants. We did sponsor some of the National Academy of Sciences, which advises JD, used to advise Dr. Williams before me, him and to, myself, because I wanted to have an independent medical, I started it, I want to have an independent medical group as opposed to scientific group to give us clinical opinions and clinical input about what is possible, what is not. And these are they talked about ethics and application. What is it that we are going to tell the crew when they go to a long duration missions if we don't have shorter transfer in space and without new propulsion or not having artificial gravity, which can have its own problems actually. And how do you deal with the fairness, avoiding harm, risk minimization, commitment to continuous learning? We need to discuss that. It's a human element and human factors, understanding what can be done, what should not be done. Obviously, people go in harm's way, they want to, having a, you go to war and you don't sign an informed consent that you're going to go to war and die. It's understood, but space is not war. We are not fighting in space yet, but we need to understand what are the rights and do's and don'ts is. And here are the examples, some of the responsibilities that we are going to be talking about. In our new textbook, we are going to have a full chapter on legislation and ethics. And important open issues require future research is that what should be the new norm for spacefaring governments and industries? And Zubin did address that, I think. There is not enough information on sex, race, and age groups. We think women might do a little bit better than men, but we don't know because most of the women who've flown in space are from US. And probably less than 2% of them were had diversity, but 55 out of 67 women were US women, okay? So we flew more, but we need more to understand, or different races, we need more to understand what is their preferential responses or not. So having said that, what are the key points of emphasis? Increasing distance creates risk of its own. ISS is providing a test bed. We need to use it to the fullest. When I ask Zubin, do we need space stations? Well, you need them. We need them from biological standpoint is a test bed. It's one of the most accurate test beds that we can get access to. Robotic mission and space sciences have to continue to work hand in hand to get us response. And I think that the private sector should get involved at some point of time in supporting some space science mission, robotic missions, to understand what are the risks that we might face on other planetary or satellite surfaces. Commercial involvement and services, they're driving the change of the architecture of future space habitat technology, life support design, and services provided. Do we need people there? So we need to understand what should be good for robotics, what should be good for artificial intelligence, what should be good for people. And people should be mostly as a manager of the system, maybe. Increasing diversity is driving the need to understand, we already talked about that, and understand evolution and adaptation consequences for future settlers. If you can have children there, or is the settlements important, or should be have people return back to Earth? Special consideration, selection of training workers and passengers. There are workers out there. We are going to have workers. So how do we protect them from radiation? And also, what are the new norms for occupational health safety? The Academy of Sciences, the Institute of Medicine told us we need to put, and we agreed with them, that we need to put the whole prospect of being in space as an occupational and health safety issue, the occupational and environmental issue. Approach it like, like we do that with in the labor activities on Earth. But do we have to have the same similar laws like the labor workforce is subject to, or should we have new? Obviously, we have some problems like acoustics, and NASA team sorted very well and actually got an award for sorting the acoustic problem on space station. Develop artificial gravity. It's easy to say artificial gravity, but artificial gravity has its own problems, but it will make the technology work better. Okay, so that's a thumb sketch of what is or will be contained in the new concentration. And thank you for participating in our session. Thank you for introducing me. Thank you for being on the panel with you all, and looking forward to the future.
Thank you so much, Arnold, for a very informative presentation. And I do have to say that both Arnold and JD have written the book on space physiology, literally, in space medicine. And with their experiences at NASA, we're certainly fortunate here at American Public University to have them on board with us, developing this new and exciting concentration.
And we will write a new book with JD and Kristen, and we are looking forward to an update. You know, things have changed already. We need to tap JD knowledge.
Fantastic. I'm really looking forward to it, Arnold. This is great. We'll have the book and the curriculum. Your book will be the foundation for the curriculum. This is really exciting.
I hope we call it our book.
You see, I was going to check the chat and the questions to see. It looks like my colleagues have been answering questions in real time in the question and answer section. And but feel free to post questions. Our time frame is such that we go, I believe, till 11:40. And I have a few slides where I want to talk about another one of the courses, in addition to those covered excellently by Arnold, my colleague Arnold. Our course, Space Studies 625, New Worlds for Human Expansion, and we focus on the Moon, Mars, and asteroids. And let me put that into the slide presentation mode here. There we go. Now, this morning, our keynote speaker, Robert Zubrin, I was delighted to listen to his talk, which really set up the importance for our new concentration in terms of humans returning to deep space. This is really exciting with the goal that Zubrin had set forth, and being a visionary looking into the future, let's say 500 years into the future, that we will humanity will have colonized the solar system and perhaps have established outposts in other star systems. The Alpha Centauri Proxima Centauri, 4 1/3 light years away, we know has planetary systems. And so it would not be beyond or stretching our imaginations to think of humanity and our students laying the foundation for having humanity expand not only into the solar system, but elsewhere into the galaxy. And this is the kind of thing that excites me and gets me out of bed in the morning to know that there is such a wonderful possibilities for humanity in space and resources. And another point made by Dr. Zubrin was human population is a good thing. If we look at it as a resource for ideas, the more people we have, the more ideas we'll have, and the possibility of taking those ideas and building an infrastructure that will take us out into the cosmos is beyond exciting. I keep thinking of the Star Trek theme with humanity traveling into deep space. So anyway, we're this morning I'm going to limit our discussion to more near space, the moon, Mars, and asteroids. And you might ask why the moon, Mars, and asteroids? Well, the moon is our nearest planetary object in space, 250,000 miles away. I think if we go back in time to early human history, our ancestors looked up at the sky in awe at this brilliant orb in the night sky. And I was reminded of that earlier this week with the harvest moon, the full moon, the beautiful moon rising. We finally have clear weather here in the Atlanta area. And how the moon has called to us, as Carl Sagan would say, the stars called to us, but the moon did call to us, and that was very apparent in the 1960s with the Apollo program. Growing up in the 60s, as a kid in the 60s, that is what inspired me to become a scientist and a planetary scientist, the exploration of the moon. And it is so great to have folks like Arnold on our staff who were involved in the Apollo program to take that knowledge and share it with our students. So this course will not only explore the moon, but Mars. And why Mars? Well, of all planets other than Earth, of all planets in the solar system, Mars is more like the Earth than any other planet. It's about a third of the size of the Earth. It's smaller. The atmosphere is much thinner, 90 times thinner than the Earth's atmosphere. However, when we look at other worlds like terrestrial worlds like Mercury and Venus, or perhaps some of the moons around Jupiter and Saturn and other outer planets, Mars is an exciting planet. It's a place that humans can settle. And this is happening within, we believe, in our lifetime with SpaceX, which has been mentioned quite a bit during the conference, in their Starship out in Boca Chica, Texas. I've been following this very closely, larger than the Saturn V. Can carry, Elon Musk's vision is to carry hundreds or 100 humans in one flight and have thousands of starships going to Mars, ferrying humans to settle Mars. And we're really hoping that this will, and it looks like it's going to happen, will happen during our lifetime. So Mars is a very important place. Asteroids are, if you could design a solar system, you couldn't make it any better than the solar system we have. To put out in between the inner planets and the outer planets, between Mars and Jupiter, is a spectacularly rich, diverse belt of minerals and resources, water, most everything we need to further human expansion out into the solar system and beyond, the asteroid belt. So very, very important. Okay, so our course, this particular course will examine the potential and habitability and available resources, as I mentioned, on these other worlds, the moon, the Mars, and asteroids. Okay, so let me move my panel out of the way so I can see here. Okay, here we have a view, perhaps a not too distant view of humanity on Mars, and you can see all of these wonderful starships proposed by SpaceX. And folks like the fellow to the far left with a camera, perhaps posting on Facebook, if he or she recently arrived on Mars, this spectacular view of humans and spacecraft on the red planet. And this is so exciting for our students that that they are of the generation that will take us into deep space. They are are the new Magellans and Columbuses and Captain Cooks who will venture across vast stretches of space to call or to settle other moons and planets. This is quite exciting. So it really is, this course is about the human return to deep space and the lure of very rich and valuable resources that can sustain human developments on these worlds, and also build a foundation to take us to other planets and other vistas in our solar system. So these objects are what we consider, and we believe NASA, as well as the commercial space environment, considers the next natural steps in the human expansion and exploration of the solar system. I did want to talk about an exciting endeavor that we are involved in here at the American Public University with our Space Studies program. And this is the Lunar and Mars analog habitats. Dr. Miller has been working very closely with a group of students and a couple of faculty members who will be departing to the University of North Dakota for their inflatable lunar and Mars analog habitat. We have a mission for students that will begin on September 30th and will run for about 2 weeks. And this is something that fits nicely into our new curriculum and concentration. We also are putting together a team of students for the Mars Society's Mars Desert Research Station in Utah. And we are configuring for a mission with our students and a couple of faculty members. This would be in mid-2023. So these are some efforts that will give our students a taste of what it is like to participate as humans in the space environment. Okay, so going back to the actual curriculum and the learning objectives for the course, what I would like to do is just outline those, if I could here. Let me see. Let's go back over here. And I'm trying to remove the header. Okay, so anyway, listed here are the technical learning objectives for the course. And I'm not going to read these verbatim, but just to know our first learning objective is to consider the resources. You know, why one reason to go to the moon, Mars, and asteroids is because they are rich in resources that will allow us to continue to have human endeavors and expansion elsewhere into the solar system. The learning objective number 2, there are unique challenges, and these challenges create benefits. We solve problems, develop an infrastructure. We pave the way for a continued human presence in deep space by the human exploration of the moon, Mars, and asteroids. Number 3, materials and technologies currently being developed for use in off-world habitation. This is on the cutting edge of aerospace engineering and also biological sciences to take humans into space. And going back to Dr. Zubrin's keynote address this morning, everyday people sort of forget that we live in space. And I have to remind my wife about this constantly. She's like, whoa, why are you so obsessed with this? Because we live in the habitat of space. We are part of the cosmos. And so we need to, there's a need to develop materials and these technologies to help us live in this grand universe on this island Earth, floating in space, orbiting around a star called the sun. And our sun is orbiting around the nucleus of a galaxy called the Milky Way. And our entire galaxy is in motion through a vast universe, almost 14 billion years old. So it's a wonderful, wonderful cosmos that we live in. And humans are naturally drawn to the exploration of space, to go out and see what's there. Okay, number 4, again, to understand the infrastructure needed to create these settlements on these objects. And this would involve logistics, services, communication needs. And here is where I believe the Space Force definitely can come into service. Quite naturally, if we look at the history of human exploration and settlement of the Earth, the military has always taken the lead. Captain Cook and his voyages. The science and technology rode on the coattails of the military exploration. And I think this will be true as we venture out into deep space. A lot of people don't know this, but even Carl Sagan, who was somewhat of a pacifist, Carl Sagan advocated the military, that the military take the lead in the exploration of space. And this is because they have the infrastructure and the individuals who can really make this happen, the organization to make this happen. And finally, our last learning objective, at least what we have written here, which is subject to modification, is to take a look at the roles of NASA and our commercial space partners in supporting human exploration and settlement. And especially looking at for some possibilities for international partnerships in these ventures. We are a species, the same species, with different cultures, scattered across the planet with a similar goal. And nowhere else do we see humanity coming together and working together for the general good of our species than in the exploration of space. Okay, I think I might have one final slide. Just to give you a heads up, Arnold, I'm going to turn it back over to you. We've after I say something about the slide, we have about 10 minutes, and this is really Arnold's baby and his expertise. Both and Chris, Dr. Biller has been assisting Arnold with this, but this is his baby. So I don't want to take up too much time. I want Arnold to have the last word. The case for human exploration. These are reasonable goals for humanity in the next step. And I wanted to show this, and I am so excited about the Starship, the really big rocket that SpaceX is building in Boca Chica, Texas. And we're going to see a launch probably within the next month, suborbital flight of this huge rocket, larger than the Saturn V and capable of carrying 100 people to the moon, Mars, or to the asteroid belt in one shot, and significantly reducing the costs of exploration. The other case is there are unique resources out there in the solar system, whether we're talking about the moon, Mars, or asteroids, and these create challenges, and humans love challenges. I know our students love challenges and opportunities. There will be a huge workforce on their way to the moon, Mars, and the asteroid belt. And finally, in summary, our course will take a look, as I mentioned before, at the infrastructure and environmental needs. What does it take to, as Arnold and JD had talked about earlier, to keep humans alive in the space environment? It can be very hostile, but at the same time, we have the technology to make it happen. And I can recall, I think it was Pete Conrad of Apollo 12 who said he actually, of all aspects of the Apollo mission, he actually felt the most comfortable and at home when he was en route from the Earth to the moon. He said space in their Apollo capsule seemed very benign and welcoming. They were traveling at high rates of speed onward to the moon, but there was nothing to collide into, or they had already fired their engines and they were on their way. So he was very comfortable and felt natural in the environment of space. Okay, so that's all I have to say. And Arnold, you vanished off my screen, but did you want to say a few final words, perhaps both you and JD?
Yeah, first of all, I would like to thank Daniel and Paul Rich and the provost and Angelique for getting us on this panel and to have it going. I think that was very useful introduction to launch the consultation that you are so closely following, Ed. I would like to thank both JD and Kristen for all the things that they said, and I'm looking forward to finish that presentation. You know, it's one thing to present it, the other one is to finish the consultation. So let's go do it, and I'm sure that we'll have a lot of interest and a lot of partnership to be developed in the process. Thank you.
Thank you, Arnold. And JD, do you have some closing thoughts for us?
Thanks, Ed. Well, first, just a comment that some great questions from the audience and gallery, and it shows how many different facets there are to these questions. There are ethical components, there are fiscal components, there are just political components to it. There's just a lot of different facets. Yeah, the more questions that we got, the more I thought, boy, that you could do a breakout course just on that particular aspect as well. And so great questions, and I think you can tell the subject matter definitely resonates with folks. This is, spaceflight used to be the domain of governments, and now it has quickly moved to the private and commercial sector. But also, it's interesting to see where the space and how everything's evolving. And so I think you're going to have those three sectors, the military sector, the government sector, and the public-private sector, all expanding rapidly because it is, to kind of merge Captain Kirk and the Space Force mantras. It is the last fighting domain and also the final frontier all at the same time. And so it's very interesting to see where this is going, and certainly no shortage of opportunities for careers and jobs in the future. I know the provost Vernon and I have talked about, what jobs will be available for space. And I said, pretty much take any job and put the word space in front of it in the future. And I've looked at even something like procurement, where you needed to have some knowledge of the space business to go and work in our procurement at NASA. You had to have some context as to what we were doing for the procurements and contracts. And it's just amazing to see how that's changed. And also intermittently, I look at the job offerings on SpaceX or Blue Origin or Axiom, and et cetera, just to see the types of jobs that are out there. And it's not just engineers. There's just a plethora of different openings, and the aperture keeps getting wider on the different expertise that they need in those companies for space. So it's an exciting time for us, and it's an exciting time in the agency to do exploration and to concentrate on Artemis and Gateway. And we've got 8 different vehicles that we're working on right now, including 2 X-planes. And it's just, never in the history of NASA have we had 8 vehicles in development simultaneously. And then the commercial space flight on top of that, and Space Force as well. It's just a really amazingly exciting time in space in general.
Thank you so much, JD. And I am really excited about the Artemis mission, appropriately named following Apollo and the Space Launch System that's currently under development. I've been following, my 2 favorite things to do is to follow NASA's progress with the Orion spacecraft and the Space Launch System, which is being stacked, currently being stacked for the first test flight in the vehicle assembly building. Following that, as well as the Starship out in Boca Chica. And got about 2 minutes left. Dr. Miller, would you like to offer some closing thoughts?
Oh, sure. Thank you. I would just say that it's been a privilege to develop this concentration with Dr. Nickagosian, and that I'm excited for these topics. I think that they're relevant. I think that they will be useful for students, and I'm excited to see how we can pair this with the analog research that we're doing at APUS. I think it'll be beneficial for our students. So we hope that that everyone will be very excited about it. Thanks for some really great questions in the chat, and we look forward to seeing you in the classes.
Thank you so much, everyone, our panel and our attendees. Very, very good questions. If you have additional questions, feel free to reach out to myself or my team. My email is ealbin, ALBIN, @apus.edu. Have a great afternoon, and keep reaching for the stars, as we say.
Yeah, just to add up to that, Ed, may the force be with the concentration.
Yeah, absolutely. Okay.